Hi, my name's Alex Thornton. I'm a Linux kernel engineer, or Linux kernel hacker to some. I've been doing that professionally for about 10 years now. I originally started at SGI, worked there for a number of years before they were absorbed by Hewlett Packard, and also worked at Cray Incorporated for a while before they were absorbed by Hewlett Packard. And now I'm working at a different company doing a different flavor of Linux kernel work. I won't mention the name here because I'm pretty sure I have to ask HR before I do that. But not too hard to find out if you want to dig around. Anyways, I've been doing Linux kernel work for basically my whole career at this point, and have maybe somewhat obviously always had a pretty deep interest in Linux and computer hardware and software, and particularly old video game hardware. And that's sort of what led me here today to make this video and work on this project that I've been working on here for a number of years. So basically, what I've been doing is trying to get the Linux kernel running kind of standalone on Nintendo 64 hardware, starting off in an emulator, just because it's easier to debug and work there. But I'm hopeful that I can get it running on hardware. But anyways, what I've got here is basically a bunch of research I've done, a bunch of stuff that I pieced together to make this get to the point that it is today. It's not quite all the way there, but actually I just made a bit of a breakthrough tonight, even while trying to record a few previous takes of this video, that it's actually working better than I thought it was. So there's a little bit more of an impressive show than I was planning to be able to put on here. So that's a good thing. It'll be a little less boring than what I thought the video was going to actually be. Anyways, no, like I said, been working on this for a few years. I originally started doing some research into it by looking at a few things that people had done before me. A library called LibDragon that a person named Sean Taylor created in, I believe, 2009, and that was basically just some helper libraries to let people write pretty basic C programs for the Nintendo 64 hardware. I didn't end up actually using any of their code or anything, I don't think, but again, it was just something that I looked at, and I wanted to give credit to those who had been here before me. So, yeah, in a similar vein, I also looked at some stuff done by a guy named Tyler Stashecki, or maybe Stachki, I'm not sure how to pronounce that, but he wrote two things, actually. A library called N64 Chain, which, from what I can see or understand, is a fairly similar idea to the LibDragon stuff. I believe that his is a little bit newer, but again, just basically, some libraries and stuff to allow you to easily write C programs for the Nintendo 64. And he also included some very nice toolchain stuff in there, which I do actually use in my work. Again, I don't use any of his code, I don't think. If I do, I will. I'll make sure to give credit of that for that before I post any of it. But again, I don't think that there's any in there. But I do use a checksum tool that he wrote in order to kind of munge the Nintendo 64 program header onto my Linux binary. That's, again, it's a piece that I need to make stuff work, but it is not. I don't directly use any of his code in my final work, but yeah, there's that. And he also wrote a cycle accurate Nintendo 64 emulator called CEN64, which I played with a little bit. Ultimately, I use a different emulator for my work, but I have used his for some just comparison and testing and stuff like that. But anyways, the stuff that I've actually am using and have worked on or wrote myself is basically two parts, 2.5 maybe, depending on the way you want to look at it. But anyways, first part that I sort of mentioned there would be the program header. I didn't want to use Nintendo's program header directly. I'm not sure what it's licensed code. I don't think they want you using it. So I actually am using an open source bit of header code written by a guy named Peter Lemon. And that's, I don't know. I don't know if he based that off of a disassembly of the Nintendo code or if he came up with it himself. I bet it's the former, but not sure there. But I do use that pretty much verbatim. I think I made some modifications to it here and there for various reasons, but it's basically just his original boot code, as he called it. And so that's in there. That uses a special assembler called Bass that I had to set up a build for and stuff. But that again, it's pretty much straight out of the box using his stuff for that. And then the other piece that goes into this is obviously the Linux binary. And for that, I am using a 4.18 RC5 kernel. I'm using an RC kernel just because that's what happened to be on master at the time. But I'm using the 4.18 kernel with some patches written, or maybe it's just one big patch, I guess, written by a guy named Alan Williams, who is somebody who was here before me, I suppose. He got the Linux kernel booted up to basically the same point that I'm able to get it to, except for he did it on actual hardware. And he used a really cool hack, very different from what I'm doing in a lot of ways, but he used a cool hack using a Game Shark and a Star Fox cartridge and stuff. I won't explain that in detail in this video, but I will post a link to his video so you can see that, because in some ways it's a little bit more impressive than what I've got set up so far, just because, mostly because the frame buffer implementation in my emulator is not working correctly right now, and I'll mention some of that later. It's almost there. It's rendering. It'll render an image. It'll create the proper image of what should go to the screen, but for whatever reason, it is not actually rendering, and it never has. But it at least will generate the images now. So that's the new cool thing that I discovered tonight while working on it, is that somewhere in updating the source code for that emulator, I built a fresh build of it yesterday, and somewhere along the way, apparently somebody at least partially fixed it, because that wasn't working at all before. But anyways, that's sort of where I gathered, all the work that was done before me that I kind of have either referenced or used some of to get here. That's all mentioned there. I hope I haven't missed anyone. If I have, I'll try to come back and make note of that. But yeah, basically, that's all the stuff that I pieced together. I use OBS, the OpenSUSE build service, or I think they just call it Open Build Service, but it's a SUSE product for building. Basically, they use it for building, I believe, their entire, all the packages that they ship for their distro. I was just using it because it's kind of a simple, not simple, but it is a reliable and existing framework for building packages for OpenSUSE, which is what I use. And so that's in there. I use that to build the tool chain, which I may have forgotten to mention. The tool chain, the GCC bin utils and make and stuff that I use. I based some of those builds off of Tyler Stashicki's work as well. So I don't think I use any of his stuff directly, but I'm building the compiler. I think I'm using the same versions that he used in his most recent stuff, and I build the compiler in a similar way, although it's all done. It's all, I wrote spec files for all of it, and it's all packaged up, so I can just RPM-I the stuff onto my laptop after it's built on the build server. And then, yeah, it's simple, nice way to build stuff, and it's been very helpful. Even though it's been very difficult to keep it all working over the years across various, OS updates and OBS updates as well. But it's still proved very useful, even despite the amount of time I've had to sink into making it work sometimes. But anyways, so we'll get on to, I'll do an actual demo here. I'll give fair warning that I have had, I had to redo the video here because I had some interesting discoveries. It's been a little flaky tonight, which never was before. This always worked the same way every time, but I believe that has something to do with the fact that the frame buffer is actually partially working now. So the first time I ran this, I ran it and it didn't do exactly, the breakpoint that I was expecting it to get to, it didn't hit. And so I don't know what's going on there. I'll have to debug it at a later time, but I wanted to get this video made because I've been trying to do it for over a year now. So, anyways, I might have to run this a couple of times, but I will get it to run. I will be able to point to and say this is panicking trying to load an init, which is as far as Alan was able to get, and as far as anybody has ever gotten, as far as I know. So we'll be able to at least see. we'll be able to prove that it gets all the way there. I'll talk a little bit about what we need to do to get further than that. And actually, like I said, I'll be able to show an image of the thing, giving at least some proof that it's actually working. I can't... the MUPEN 64 plus frame buffer stuff is lightly broken right now, so I can't actually see the video in the emulator window, but it will render up a snapshot of what would be on the video, so I can at least show you that. You don't have to believe that I'm not just faking it, but I promise that it's actually running and it's actually generating this stuff through the frame buffer driver that Alan wrote. But anyways, I'll again cover some of that in other videos and stuff, so that maybe if you see those, you'll believe I'm not lying. But we're gonna go for this here either way. So. What I've got going here is, I've already pulled this up in my window from a previous attempt at making the video here, but this is just the disassembly of my Linux binary, and I've hunted down the panic function. You can see here, if you take a look, this is just regular Linux kernel tree with a bunch of binaries I've saved off and stuff, and configs that I've saved off from various steps along the way, but I'm just going to obj dump my VM Linux here, and then we're going to hunt for panic. And I don't know can't remember if I mentioned, but basically we're going to set a breakpoint on panic because when the kernel gets as far as it can and realizes that there's no init binary, which in modern times would usually be systemd for our purposes. Someday it'll likely be busybox if we ever get that far, but there's nothing for it to do once the kernel gets booted. It gets all the way up and it says, hey, there's nothing, you didn't give me a program to run. But it will call panic when that happens, and so what I do to show where we're at is I set a breakpoint on panic, and then I examine the first argument into panic, which is the error string that it's trying to print. And so we'll be able to see once we hit the breakpoint that we are actually reaching the init failure. Anyways, we're going to go ahead and run this. I'll mention quickly here before I do run this a little bit about the invocation of the emulator here. I have to run this in emulator mode 0 for MUPEN 64 plus, which is what they call the pure interpreter, and that's basically just so that I know that the emulated processor is running the exact instructions that I am feeding it. The default mode is what they call Dynarec, the dynamic recompiler, and it's a really cool feature, it's a very... maybe I'll get it out one day here. It's a very cool thing that they've written to help ROMs run more efficiently and stuff, but for obvious reasons, that doesn't work for me, for my purposes. I need to know that the processor is doing exactly what I told it to do, otherwise, it's impossible to debug, or much more difficult, and I have a strong feeling that this would never work with the dynamic recompiler. But anyways, yeah, so we've got that there, and then I've also got the debug switch set here, which just tells it to pause before starting to run the ROM so that I can set breakpoints or do whatever I want, and that's what we will do. So I'm going to run it here, and I'm going to bring the video over here, or the window over here. You can see there's no output on it. I'm going to put it underneath here. It's not going to show anything, but I'll scoot it over this way. So this is where you'd be able to see something if it was working, but you can't. So anyways, we got it running here. We are going to set a breakpoint at the panic address, as I mentioned. Paste that in there. And we got that set. Now, like I said, it's never done this before, but I had to run this a couple times to actually get it to the panic the last few times. So I don't know what the deal is there. I'll debug it later and hopefully make another video to explain it. But at least for now, we will do it until it works, and then I will show you that it worked. So we're running a bunch of debug output here. Oh, good. It worked on the first shot. So you can see here that it has, in fact, reached the... it's a program counter at the address that I told it to stop at, so we know we're at the panic function. And what we're going to do here, if you know a little bit about MIPS architecture, we know that register A0 here is argument 0 into the function that was just called. So we know that it'll be our error message string, or should be. So we're going to use this str command that I actually added to the MUPEN debugger for this particular purpose to see what the panic message is. And so we'll run that, and you can see here as promised, this is the no working init found message. Please pass init equals on the command line. And so, yeah, that is as far as we can expect this to run. This is as far as Alan was able to get on hardware. And again, nobody's going to get any further than this until they either create an initRD that contains a binary for the kernel to run, or do something else. That would be the first step, in my opinion, would be to do it through an initRD, but nobody's done it at all yet, so it's, I guess, up for grabs if somebody wants to try to figure out another way to do it. There are obviously a number of ways you could do this, but we can see our error message here. We know we are as far as we can possibly get, and what I'm going to do is I'll try to find the image that would have been dumped out for the last frame here. So over here, or up here, we can see it wrote a PNG file, and it looks like the last one that it wrote is 7F928. So let me check in my home folder over here for that image. Where is it? 7F9283. Did I say 38 before? Whatever, it doesn't matter. So we'll open that up here, and I'll drag this over onto the screen, and you can see this is what we would expect here. I've got the resolution cranked up, and I'm using a kind of weird font, I believe. So it's kind of hard to read. I mean, you can tell this is a this is Linux boot screen, or boot output with the little penguin that I made sure was compiled in, so it at least shows something cool. And yeah, like I said, you can't really read this very well, just because the font's tiny and the resolution is cranked up. I believe the default resolution on the N64 is 320 by 240, and I've cranked it up to 600 by 480, 640 by 480. I can't remember the exact numbers. Doesn't matter. Point is it's cranked. The resolution is a little bit higher, so we're not getting. This text is really tiny and kind of hard to read, but you can see if you look closely here that the last message out is not actually the panic message that we expected, and I believe that's just because once it panics in this manner, it never writes that last frame to the frame buffer. It skips out and it's done. It's sitting in a panic loop where it's not doing any more work. So that last line never makes it to the screen. But I do believe that random fast init stuff is usually the last thing that you see right before you would see that panic message. So, anyways, that's the demo that I have at this point. This is as far as I've gotten, but again, as I said before, I'd never seen this image until tonight. I don't know what the reason was that it wasn't even generating the images before, but it clearly is working to some degree now. It's just not, as you can see here, I'll pull the emulator up, it doesn't render. And I don't know why that is, because this PNG here that it generated is the texture that it would be trying to map onto this frame buffer rectangle or whatever, but it doesn't work. And I have done some debugging on that, not much, but I have not figured out why it's not working at this point. But we'll get there someday, and I will certainly make another video about that once I fix it, because once that's working, we can toss this on hardware and maybe reasonably expect it to do something. And in fact, we may be able to do that even now. I have not tried this on hardware since I saw this start working. So there could be a whole nother fun video waiting to be made already. But we'll get there at some point. But anyways, yeah, that sort of leads me to my what's next portion of things, and that would be at this point, I would like to try this on hardware, and I'll certainly make a video of that. And then beyond that, there's a lot that can be done from there. As I mentioned, we need to get some kind of file system set up so that it actually can run an init binary, which will, as I may have mentioned, likely be some sort of busybox or something to begin with. And we could certainly move on to creating an actual file system in cartridge memory and get some sort of, get beyond just having a kernel running a bash prompt or whatever and get to actually a very bare bones operating system. And beyond that, there's the potential of even using the N64 disk drive to get a somewhat full-fledged operating system. Now that's a pretty that's a pretty pie in the sky goal, and it gets away from my real goal here as well, in that I'll probably never get my hands on an N64 disk drive at this point, so I won't be able to do it on hardware, and it kind of defeats the purpose to me. I want to see the machine actually do this. But yeah, those are a couple things that I might look into. I obviously at some point would like to be able to give the thing input as well. And I think some keyboards actually do exist for the N64. I think, similar to the N64 disk drive, I'm never going to get my hands on one of those. But I do have some ideas for ways that I could hack one together. I don't actually know exactly how the N64 handles controller input. For instance, on the NES, it was just a memory map register, if I remember correctly, that basically you would pull that register on every VBlank, and you could see if a bit was set, it would imply that that button had been held across that VBlank iteration or whatever, and then you would clear that register, and that's how you would do input. You would pull at every VBlank and then read the bits from there. And it may well be a similar thing on the N64, I'm not sure. But what I'm getting to is the N64 does have enough buttons on the controller that using button combinations, you should be able to map a full keyboard's worth of input through the controller. And so realistically, it's possible that I could just hack a keyboard together that uses different button combinations as a way to represent key presses, and then we'd obviously have to do something on the Linux side to reinterpret that back into something it understands. But yeah, that's if we ever get to that point of doing input, that's most likely the way that it'll have to go on real hardware, because again, I'm not probably never going to get my hands on the on one of the keyboards. But yeah, aside from that, the one more cool thing that I would love to touch on someday, which will obviously be another video and most likely another whole series, would be getting an actual non-Nintendo rip-off header. And until recently, there wasn't much hope for that, because they had they signed. I'm going to say this wrong. I'm not super well-versed in the whole checksum generation thing and everything, but basically their header expects it checks itself. It checks its own checksum. And, I'm sorry, this is where I'm wrong. The hardware checks the checksum of the header that you feed it, and unless it matches some blessed value, it won't boot. The machine won't start. And somebody has actually written what they call a hash collider to determine a sequence of bits, or a sequence of information that you can append onto your header to trick the hardware basically into generating the same checksum that a actual licensed Nintendo header would have generated. It's a really cool concept. It's the concept of hash collisions exists, externally as it's its own thing. It's not just something you would encounter here, but the fact that somebody wrote this thing is really cool. Now, I don't know if it's mathematically correct. I've looked at it, but it's very hard to say whether or not the code that they've written to generate this new hash actually works. But no matter what, it's going to need to be run on either some type of bigger iron than I have here, or a small cluster of the types of iron that I have around here. I'm not sure which way we would go with that, but yeah, that's basically what that's another future thing that I would love to touch on, but is a whole different project and will probably take me years to get working. But again, I'm making the videos here to get some of this out there, maybe get people interested in it, and also perhaps to motivate myself to actually do some of this. But anyways, that's all I've got for now. But I hope that you enjoyed this, and I will certainly try to make some more videos explaining some of this stuff in more detail, and then I will obviously try to make more videos showing some of this stuff working better as I get it working better. So thanks a lot for watching, and I'll see you soon.